Welcome back to Easy to See. We have already learned the techniques of simplifying Boolean expressions or switching expressions by using Boolean algebra. In today's class, we will be learning another technique which is Karnaugh Map or K-map. By using Boolean algebra, when we simplify Boolean expressions, we have noticed that as the number of variables increases, the complexity of the simplification also increases. And sometimes we cannot make sure that the simplified form that we have obtained, whether that is the most simplified form or not. In those scenarios, K-map helps us. In today's class, I will give you the overview of K-map, and in the following classes, we will be simplifying several Boolean expressions by using 2, 3 and 4 variables K-map. So let's get started. So first, what is K-map? K-map is a systematic graphical technique to simplify and manipulate Boolean or switching expressions. Now, when we will be simplifying Boolean expressions, definitely that will be given either in the SOP form or POS form. That means in terms of Minterms or Maxterms. K-map is a tabular form where we have multiple rows and multiple columns. That means a K-map will have multiple cells. And how many cells it will have, that will depend on how many variables that particular function is represented by. So if that function is represented by n number of variables, then in that K-map, we will have 2 to the power n number of cells. That means if the function is represented by 2 variables, then we will have 2 raised to the power 2, that means 4 number of cells. And this is the simplest form of K-map that we use in simplification. In this K-map, we have 4 cells represented by dark borderline. As I said, this K-map is for 2 variable functions. So first what we will do is we will mark those variables. So here the variables, if I assume as A and B, so A and B, we have arranged the variables in this in anti-clockwise order, or we may arrange the variables in clockwise order also, but that has to be cyclic. Now we know that every Boolean variable has 2 values, logical high and logical low. That means 0 and 1. So for a variable also, it will have 2 values 0 and 1 that we will mark as header on top of every cell. And for B also, that we have marked, for that also we will be marking its possible values which are 0 and 1 beside these cells. In later part of this class, we will see that if we have 3 variables or 4 variables K-map, then how we can mark their values. But whatever, we have to remember one important point, that when we are arranging the variables, we should arrange such a way that between 2 adjacent cells, the change in value should be for one variable. And this is one important relationship which plays a very important role in simplification. Here x is that variable whose value changes between 2 adjacent cells, and with that variable, if we have any other variable, then for that the value is a, which remains constant. This will be more clear in later part of this class. And after marking all these variables and their values, we also mark each cell in that K-map, and that we write inside the cell. Next, we will learn K-map in bit detail, variable wise, and also we will learn how to group different cells. So first we will start with 2 variable K-map. So this is a K-map where we can see that we have 4 cells whose boundaries have been darkened, and we know if we have 2 variables, then the number of cells will be 2 square, that means 4. Now if the variables we assume that A and B, then this is the complete truth table for 2 variables. Now this is the marking of the variables and their corresponding values that we have already seen, and these are the decimal numbers corresponding to each combination of A and B. And since we have 2 variables, so 4 combinations, that means from 0 to 3. Now next our task will be to mark each cell in that K-map, and here we have 4 cells, that means we will be marking from 0 to 3 only. Now how will be the marking? So as we can see here, the variable A here has value 0 and variable B also has 0. So what is the corresponding decimal number? It is 0. So we will mark this cell by 0. Now the next combination is what? Next combination is A is 0, B is 1. And if we go by this order, then A has 0 here and B has 1 corresponding to this cell. That means this cell will have value 0, 1 and corresponding decimal number will be 1. So that will be marked accordingly. Similarly, if it is 1, 0, then the corresponding decimal number is 2. So A is 1 and B is 0. So this cell will be accordingly marked by 2, and the last cell definitely it will be marked by 3 only, where the value of A is 1 and B is also 1. So this way we complete the marking a K-map having two variables. But our main task is to simplify Boolean expressions using K-map. So first we will learn how to fill all these cells by their corresponding values, and then in our following classes we will be learning the techniques of simplification. So suppose if we have a Boolean expression like y, where y is a combination of these two main terms a bar b bar and a bar b. So what we will do is a bar b bar means the corresponding decimal number is 0, and that we have already learned in the class of Minterms and Maxterms. So that means corresponding to this min term, we will fill this cell by 1. Next min term in that expression is a bar b. Its corresponding decimal number is 1. That also we know. So this has the decimal number 1. So this cell will be also filled by 1. And in our class of SOP and POS, we have also learned that canonical SOP for all these min terms, the value of that function will be 1. And for the rest of the min terms that are not part of that expression, for them the value of that expression will be 0. So those cells in the K map will be filled by 0. Now how to get the most simplified form, that we will learn in our following classes. Next we will learn K map for 3 variables. So 3 variables means how many combinations? 2 raised to the power 3, so 8 combinations. And as we can see here in this K map, we have 8 cells which are represented by dark boundaries. Now this is another form where we also have 8 cells, and this is the truth table for 3 variables. So again the combinations will be 8, and the corresponding decimal number will be from 0 to 7. Next our task is to mark the variables and their corresponding values. Now here A, B, C, these 3 variables have been arranged in this order, means in clockwise order. But even if we arrange all these variables in anti-clockwise order also, finally after simplification we will be getting the same simplified answer, but we have to take care of the values of the variables when we will be writing as headers here. So if we go by the first arrangement, then A, B, C. So A, B, C, the first decimal number is 0, and for that the combinations are 0, 0, 0. So here the value of A is 0, B is 0, and here value of C is also 0. That means the first cell will be marked by decimal number 0, and accordingly all other cells will be marked. One point that we have to take care of is between two adjacent cells, the change in value should be for one variable only. So if we look at vertically, here we have only one variable. So for that the change in values will be from 0 to 1. Since we have a single variable here, so we will not face any issue here. But when we will move horizontally, as we have two variables here, so we have to take care of that point. So first value of AB, if we assume that we have only two variables, then AB the first value is 0, 0. That is fine. The next combination is 0, 1. So if we closely monitor here we have no change in value for A, but the value for B changes. So altogether from this cell to this cell we have change in value only for one variable, that is V. But as per the truth table, after 0, 1, the next possible combination is 1, 0. So suppose if we write 1, 0 here, the next value, then what will happen? The change in value for A will be from 0 to 1. So that means A changes its value, and again for B also, B is becoming from 1 to 0. So that means here the change in values will be for two variables. But that is not the rule of simplification using K-map. Now the next possible combination for AB is 1, 1, and if we look at the change, then A is changing value from 0 to 1, but B remains same. That means altogether here the change is for one variable only. Now from 1 1 2. Now if we write 1 0 here, then we can see that A remains same and B changes value from 1 to 0. So here also the change in value is only for one variable. So this thing we have to remember and take care of. Now will be the filling of the cells by their corresponding decimal numbers. So first cell has been marked by 0. Now the next cell, this cell, for this cell A has value 0, B also has value 0 and C has value 1. So 0 0 1 and corresponding decimal value is 1, and all other cells also follow the same rule. Now if we go to this pattern where we again have 8 cells, and now if we mark the cells by their corresponding decimal numbers, then this will be the combination. You can verify with this truth table. Now how to fill all these cells by the values that we will be having in a given Boolean expression. So this is a Boolean expression where we have 4 minterms. Only for these minterms, the corresponding cells will be marked by 1 and rest of the cells in that K-map will be marked by 0. Now how to simplify after marking, that we will learn in our following classes. So this will be the marking. You can easily verify the values of these cells with this truth table for these minterms. Now next is K-map for 4 variables. So 4 variables means we will be taking A, B, C, D. So 4 variables means 2 raised to the power 4. So total 16 combinations. That means in that K-map we will be having total 16 number of cells. Now this is the truth table for 4 variables and this is their corresponding decimal numbers. So 0 to 15 as we have 16 combinations. Now our next task will be the marking of the variables and their corresponding values, and this time as we can see row wise and column wise means vertically and horizontally we have 4 cells. 4 cells means here we will be having 2 variables. So horizontally and vertically we will be having two variables. So A, B, C, D. And now the next task will be marking of the cells by their corresponding decimal numbers. So this is the complete set of their cell numbers. Now if we want to fill all these cells by their corresponding values which we will get from the given Boolean function, whether it is SOP or POS, then what we will do, first we will analyze that Boolean function. So suppose this is a Boolean function where we have 4 minterms. So for only these 4 minterms, that Boolean function or this expression will have 1 as they are minterms, and for all other minterms that Boolean function will have 0. So this will be the values. Now you can easily compare this set of values with the truth table for all these minterms. So far we have learned the marking of the cells and the filling those cells by their corresponding values for the given Boolean function. But our aim is to simplify the given Boolean function to its most simplified form, and for that, before simplification, we need to follow some steps and an important concept which is grouping. Next we will learn grouping of adjacent cells, and in today's class we will be learning the technique of grouping 2 adjacent cells and 4 adjacent cells. Now the question comes that what is adjacent cells? So 2 cells are said to be adjacent if they differ in only one variable. Now here we have a K-map which is for 2 variables because we have 4 cells here. Now these are the markings of the variables and their corresponding values, and these are the marking of the cells. 2 adjacent cells we can group. Now adjacent cells in this K-map will be this 0 and 2, these 2 cells are adjacent, and also 1 and 3, these 2 cells are adjacent, so we can group them. And also 0 vertically, 0 and 1, these 2 cells are also adjacent cells, so we can group these 2 cells as well. And again vertically 2 and 3, these 2 cells are also adjacent cells, so we can group them. So that means for our 2 variable K-map we have 4 possible combinations of grouping of 2 adjacent cells. Now if we move to 3 variable K-map where we have 8 cells, then the possibility of combining or grouping 2 adjacent cells will be more definitely. So here if we go horizontally, then 0 and 2 are adjacent cells, 2 and 6 are also adjacent cells, 6 and 4 are adjacent cells, likewise 1 3 3 7 7 5 are adjacent cells. And if we go vertically, then 0 and 1 are adjacent cells, then 2 and 3 are adjacent cells, and likewise 6 7 4 5. So this will be the complete list of groups of two adjacent cells for a 3 variable K map. Now if we notice these two last two combinations, they are between 0 and 4 and 1 and 5. Now apparently it may look like that cell number 0 and cell number 4, these are the boundary cells, they are not adjacent cells. But if we go by the definition of adjacent cells, then the adjacent cells are those cells where they differ in only one variable, means the value changes only for one variable. This K map is for 3 variables, but if we look at the values of this cell and this cell, then value for A is 0, value for C is also 0, and B is 0. But for this cell, the value of A is 1, which changes, value of B is 0, which remains same, and the value of C is also 0, which also remains same. That means change in value is only for variable A. That means as per the definition of adjacent cells, cell number 0 and cell number 4 can be called as adjacent cells. So we can group 0 and 4 this way, and the same logic is applicable for 1 and 5 as well. So these are some possible combinations which apparently may look impossible, but if we go by the definition of adjacent cells, then that is possible. Now again we will be grouping two adjacent cells, but this time it will be for K map having 4 variables. So 4 variables means 2 raised to the power 4, so total 16 combinations. So in that K map we will be having 16 cells. So here horizontally 0 and 4, these two cells can be grouped. Also 4 and 12 and 12 8, they can be grouped. So this is the possible groups for the first row, and that is applicable for all other rows also. And if we go vertically, then 0 and 1 can be grouped together, 1 and 3 can be grouped together, and as well as 3 and 2. So these 3 are possible groups for first column, and that is also applicable for all other columns. But here I will not be talking about all these groups which are possible horizontally or vertically. These are valid groups that will be there, but here I will be talking about some special groups which will be formed by the boundary cells, as we have seen in the last case. If we consider cell number 0 and cell number 2, for cell number 0 the value of AB is 0 0 and value of CD is 0 0, and for cell number 2 the value of AB is again 0 0 and the value of CD is 1 0. So for A, B and D, their values remain same, only value changes for variable C. So here also the change in value is only for one variable. So as per the definition, cell number 0 and cell number 2, these two can be grouped together, and same logic is applicable for cell number 4, cell number 6, cell number 12, cell number 14, and also for cell number 8 and cell number 10. So this is the complete list of these type of groups. Now the same type of groups is also possible from boundary columns of the K map having 4 variables. So this is the complete K map and these are the corresponding cell numbers. Now here horizontally, vertically, all other groups are possible, they are valid, but I will be only talking about those groups which will be formed between boundary columns. So here if we look at cell number 0 and cell number 8, then for cell number 0 the value of AB is 0 0 and value of CD is 0 0, and for cell number 8 the value of CD is 0 0, that means same values, and value of AB is 1 0, that means the value of B remains same, only value of A changes from 0 to 1. So between cell number 0 and cell number 8, among 4 variables, only variable A changes value. So as per the definition, cell number 0 and cell number 8 can be grouped together, and that logic is also applicable for cell number 1 and cell number 9, cell number 3 and cell number 11, and also for cell number 2 and cell number 10. So this is the complete list of that type of grouping. Next, we will learn grouping of 4 adjacent cells. So, grouping of 4 adjacent cells or 4 cells are said to be adjacent if they differ in 2 variables. So, this time the change in values will be for 2 variables. So, first we will learn by a K-map of 2 variables, where variables are a, b, and we know their values and their corresponding cell number. So here we have only 4 cells. So here we will have only one group possible, and that is between all the cells. Now if we look at all these 4 cells and their corresponding values, then we find that value of a changes from 0 to 1 and value of b also changes from 0 to 1 among all these 4 cells. So for all these 4 cells, here the change in values is for 2 variables. Now if we look at K-map having 3 variables, so this is the arrangement of the variables, their values and their corresponding cell numbers. So here between 0 to 1, 3, now if we consider the change in values, the changes in values are for 2 variables which are b and c. So these 4 cells can be grouped together to make a group of 4 adjacent cells. Now if we look at these 4 cells, here also we have changes for 2 variables. So these 4 cells can be grouped together to form a group of 4 adjacent cells. So this is the list. Now from the same K-map, we will form different set of groups having 4 adjacent cells. This time we can see that between 2, 3 and 6, 7, what are the changes? Here also we have changes for 2 variables that are for a and c. So this group is possible. And if we consider 0, 1, 4, 5, then we can see here that for 0 and 4, if we go horizontally, then a changes its value from 0 to 1, b remains same, which is 0, and c also changes value from 0 to 1. That means between 0, 1 and 4, 5, this type of group is possible. So this is another group of 4 adjacent cells, and this is the list. Now there will be another kind of groups having 4 adjacent cells from the same K map, and this time now if I evaluate 0, 2, 6, 4, these 4 cells, then we can see here that here for all these 4 cells C remains same, and that is 0. Now horizontally if we evaluate the change, then we can see for variable a first remains same, then from 0 to 1 it changes its value, then again it remains same. So that means there is a change for variable a. Now if we evaluate variable b, then b first changes value from 0 to 1, then it remains same, and then again it changes value from 1 to 0. That means there is a change in value for b also. So there is a change for 2 variables in these 4 cells. So grouping of these 4 cells are possible, and this is a group of 4 adjacent cells. And the same logic is also applicable for 1, 3, 7, 5. And this group will be also a group of 4 adjacent cells. Now again we will learn the grouping of 4 adjacent cells, but this time for K-map having 4 variables. So this is the K-map that we are already aware of, and this time I will not talk about all the groups which are possible horizontally or vertically. I will talk about only for the special groups. So here between 5, 7, 13 and 15, if we evaluate the changes, then we will see that changes are only for 2 variables. So these 4 cells can form a group of 4 adjacent cells. And also between 0, 8, 2 and 10, if we evaluate their changes, then we will see that changes are only for 2 variables. So 0, 2, 8 and 10 will also form a special type of group of 4 adjacent cells. And also if we evaluate these cells 1, 3, 9, 11, then we will see these 4 cells can form a group, and also 0, 4, 2, 6, this 4 can form a group, and also 12, 8, 14, 10, this 4 can form a group, and this time also logic is same. There will be changes only for 2 variables. And also between 0, 1 and 8, 9, one group is possible, and between 3 to 11, 10, this group is possible. and between 4, 12 and 6, 14, this group is also possible for 4 adjacent cells, and this time also logic is same. So in this class I have given you an overview of Karnaugh map or K map. In the following classes we will be solving Boolean expressions using K map for 2, 3 and 4 variables. So stay tuned. Thank you.